I got homework, bruh. In this video, we'll talk about the top 5 methods you can use to making solving these equations from hell a little easier. Without wasting more time, let's get to it. The first method is the easiest, graphing. All you need is a graphing calculator or software and, of course, the equation. In this example, let's try f of x equals x minus 4 squared minus 4. And we're trying to solve this for f of x equals 5. When we graph this out, we can see that the parabola intersects f of x equals 5 2 times. The two x values that touch this line are the solutions to solving the parabola, given f of x equals 5. In this case, the two x values are x equals 1 and x equals 7. Easy, right? Now, with everything, there are different cases. We've just reviewed 2 solutions. You can also get one solution or no solutions. Let's explore each one. If we change f of x equals 5 to f of x equals negative 4, you can see that the parabola touches the line only once. This usually happens when the y value of the vertex is represented by the line. Now, let's try changing f of x to negative 7. If we look at the domain of this function, y is greater than or equal to negative 4, negative 7 isn't greater than negative 4, so the parabola will never touch it, giving us no real solutions. Next up is the square root method. There's 2 versions of this, one which can help you solve a quadratic with no linear term, and a quadratic in vertex form. Let's look at the one with no linear term. In the absence of a linear term bx, leaving us with ax squared plus c, or k, we can isolate the quadratic term and take the square root of each side. This is really easy, just watch. If we were given f of x equals x squared minus 4, and we were trying to solve this given f of x equals 0, we would first combine the equation, giving us x squared minus 4 equals 0. Now, we get x by itself, so we add 4 on each side. Now, we're left with x squared equals 4. This is where it gets a little interesting. Instead of simply saying x is equal to the square root of 4, we always have to include a plus minus sign. This is because both the negative and positive version of the square root will always equal to the number before getting square rooted. For example, negative 2 to the power of 2 is equal to 4, and 2 to the power of 2 is also equal to 4. Applying this, we are now ended up with x equals plus minus 2. Now this factoring when the quadratic is in the format of a x minus h squared plus k. This is the exact same process as the previous method, but with one extra step. Let's say we have f of x equals x minus 3 squared minus 4, and f of x is equal to 0. First, we would change f of x to 0, and now we get the constant on the other side. Now, we take the square root with the plus minus sign, and we add 3 to both sides, giving us x equals 3 plus minus 2. It's really simple. Now, let's cover factoring. This can get a little tricky, but it's fundamental to solving quadratics. There's a flowchart I follow when factoring out quadratic equations. First, check for a common factor. If there is one, factor out the GCF and count the amount of terms. If there's no common factor, then just count the amount of terms. If there's 2 terms, try and see if it's difference of squares, difference of cubes, or sum of cubes. If there's 3 factors, factor into 2 binomials using the box method or splitting the middle term. I'll explain this more later. If you have 4 terms, factor by grouping. I know, that's a lot of info, but let's try out some examples. First, let's try x squared minus 2. Since it's 2 terms, we have to decide if it's difference of squares, difference of cubes, or sum of cubes. This is obviously difference of squares. Since we can write negative 9 as negative 3 squared, we can factor this out as it's written in the flowchart. Super easy. Next, let's try x squared minus 4x minus 21. Since we have 3 terms, we can use the box method. We can add x squared and negative 21 diagonal to each other. Now, we must find 2 numbers that multiply to negative 21, but add to 4. In this case, it's negative 7 and 3. Now, we add these numbers to the missing spots and add an x to the end of each number. And we find the common factors vertically and horizontally. take these numbers and boom, fully factored. Last, let's try x squared to the power of 2 plus 4x plus 5x plus 10. Now, don't be scared, this is really easy. Since there's 4 terms, we can group them into 2 binomials. Now, we find the greatest common factors of each binomial and throw it outside the parentheses. If done correctly, both sets of parentheses should have the same value. So, we simply group that value together and group the left out factors together, leaving us with 2x plus 5 times x plus 2. Fully factored. Quick note, if the equation isn't asking to solve for 0, we always force it to solve for 0 in this case. We're almost done. Now we have solving by completing the square. This is relatively easy. Let's say that we're met with an equation that has no common factor, like the one on the screen. 4 times 2 equals 8, but when we add them, they're not equal to 4. There's no other combination out there that gives us 8 but adds to 4. In this case, we must complete the square. To find the square, we must take b, or the middle term, divided by 2 and find the square. So, in this case, it would be 4. Now, in the middle term, we add 4, and we also subtract 4 from the constant, or c, to balance it out. Now, we can see that the first 3 terms are a perfectly squared trinomial. So, we factor this out, and we solve the constants, leaving us with the final answer. If we're trying to solve for a certain y value, it's the same process, but a bit different. Let's say we're trying to solve the equation on screen. We would get the constant to the other side, and apply the same technique as before, giving us x equals -3 plus minus square root of 6. Lastly, they're solving with quadratics. The equation is on screen, and it does look a bit overwhelming, but it's not that bad. All we really have to do is plug in the values that we're given, and then we simplify. For example, let's try this equation. We can take the a, b, and c values, plug them into the equation, and simplify. If you can't solve the square root, leave it as is. If you can, find both values. We can also look at this portion right here. If we get a value of 0, we have one solution. If it's positive, we get 2, and if it's negative, we get none. Let's try one more to make sure. Let's say we have x squared plus 4x plus 3. First, get all 3 values, 1, 4, and 3 respectively. Next, plug them in as shown, and simplify as much as we can. Since we can simplify the square root, we would find the 2 roots, or solutions.